Right. Hello there. This is Miss Weaver, and I just wanted to show you how to use StatCrunch in Chapter 2. So this first part will be when we're looking at the qualitative data. And so this is just one of the homework questions from Chapter 2. We have this data here, and I'm going to use this little icon to open in StatCrunch. And I'll put these side by side. Uh-oh. Well, let me try that again. Let me go in through here maybe. Oh, StatCrunch doesn't like me right now. Okay, so I don't know what changed, but apparently now StatCrunch finally opened when I went here and said open in StatCrunch. So first of all, in order to get these relative frequencies, you can absolutely just use your calculator, add up all the frequencies to get the total, and then divide each of these by that total. That will get you the relative frequencies. However, you can also do this in StatCrunch. So we can do it by graphing a bar plot with summary, because this is summarized data, right? This is, if we had the actual data, we would have lots and lots and lots of really, or rarely, never, sometimes, most of the time, always, just listed in one column. So we have our responses, those are our categories, and then our frequencies are the same thing as our counts. Now with this bar plot, I don't want a frequency bar graph. That would just give me the numbers again. Instead, I want a relative frequency. And then we need to be careful because the very first time I did this, that's the only thing I changed was relative frequency. And when I computed, I didn't really pay attention. And I looked at my relative frequency. So you can see there, 0.0259 would be 0.026. And I just put these frequencies in just as I got them here. So, that one was first, second, third. And I didn't really pay attention to the labels here. And the labels have been alphabetized. And we don't want that. So instead, we want to use the worksheet order, the order that's in the worksheet. And we can compute. And now I have never, rarely, sometimes, most of the time, and always. So I can use these. Now your numbers might be different. Let's see here. So I have 0.121 and then 0.264, 0.38, that'll round to 5. 0.205 and 0.026. Now be careful, it does say around to 3 decimal places needed. I've had a few people who have put in 2 decimal places out of habit and ended up getting it wrong only because they didn't round all the way to 3 decimal places. They even rounded correctly to 2 decimal places, but that MyLabs Plus is very picky. So make sure you follow these blue directions anytime you have them. All right, so there we go. Now, for the next part of this question, what percentage of respondents answered always? Well, here's our always. And this is the proportion of respondents. And so if it says proportion, I think there's another homework question where it does, then you'll leave it as a decimal. But if it says percentage, then we need to move this decimal 2 times or multiply by 100. Either way that you want to think of it. So that 0.026 will become 2.6%. And then, of course, we'll do the same thing for part C, except never or rarely means we're going to add these two together. And let's see. So that's going to be 3, 8, 5. So 38.5. Once we add and then change it to a percentage. There we go. And continue. And that wants us to do a frequency bar graph. And honestly, just between these, I can look over here and compare. And it looks like, so as far as the first three, it's either B or C for me. But then if we look at these last two here, I believe that with this always being so far down, it looks like C is going to be our best option. Now notice that said final check. You only get one chance before you have to try a new one on these multiple choice with the graphs. Now, these were frequency bar graphs. This here is relative frequency bar graphs. So notice that they basically look the same. But these are taller because they're going up to 1,000 versus just going from 0 to 1 as these proportions are. So again, though, between A and B, I see that I have an increase, increase, and then I'm supposed to decrease and then decrease quite a bit. So again, you know, looking at the yellow and purple on mine, I believe this one is the one that would be the correct graph. Okay. And continue. Then we need a pie chart. Now we can also construct a pie chart. So if I go to graph, there's pie chart. Again, we have a summary. We'll tell it the same thing. Our categories are the responses. Our counts are the frequency. And then you can either click or unclick. It doesn't really matter. This is just going to be off to the side. But if we choose this order by worksheet, it'll put them in order counterclockwise, and we'll see that here in a second, based on the order they are in the worksheet. So when we click compute, notice our colors are a little bit different, but starting with never is our green, so right here's never. Then we have a little bit more, almost half. So I'm thinking maybe this one. So the blue, see the blue to the red to the green matches up green, yellow, purple. And then the red and blue is the yellow and purple here. So a bigger portion. These two are the only two that have a small enough purple section. But this one, the green's not big enough. So that's how I would identify the pie chart. So just looking at those comparisons, looking at the graph that we made versus the one that they have. And then if you've got to remember back to chapter 1, descriptive statistics are when we do something like we did here in parts B and C. What percentage of the respondents answered? So that's describing the data set. If we want to say what percentage of the nation that this sample came from, so a national survey asked people, how often do you eat out for dinner instead of at home? And we want to know what percentage what percentage of all people always eat out. Then we're no longer describing our data set. Instead, we're using our data set to assume or infer. That's where inferential statistics comes from. To infer something is to assume, kind of an educated guess about somebody or something, in this case about this population of people who eat out for dinner. So that would be inferential. And there we go. We have a correct answer. Now, you might have noticed up here I had the question was part right and part wrong. That's because, like I said, the first time I did this, when I was checking the StatCrunch, I actually put in these numbers based on an alphabetical order over here, like I showed you at the beginning. So that is one thing that you've got to be very careful of. But you can also do a similar question. If you do miss one and you want to have that, get that 1 point out of 1 point and get the full credit, you can always go back and do similar question. All right, let me pull up a chapter 2 or section 2.2, and we'll look at how to use StatCrunch for it. All right, so here we go. This is section 2.2, practice assignment. Again, we can open in StatCrunch. I'm going to click and then select open in StatCrunch. Of course, you can open Excel if you want to, but StatCrunch has all these great options that are much easier, I think, to get to. And so first of all, of course, we want to do a relative frequency. So again, I'm going to do that bar plot with summary. Number of children is our category. And yes, these are quantitative values now, but they're still able to, we can also say that they're the categories. And then of course, let's keep them in order by worksheet. Although I do believe if we did value ascending, it would keep it 0, 1, 2, 3, 4. But just out of habit, I like to go ahead and do that. Okay, now I want the relative frequency. So again, I'm going to hover, and this asks for to type integers or decimals, do not round. And of course, these are 50 households. So we could also just double this value and make it a decimal. So 14 out of 50 would be 28 out of 100. But we also have them here, so we can do whichever. So 0.28, 0.32, 0.28, 0.1, and 0.02, I believe. Yes. All right. Good job. I like the positive reinforcement. So what percentage under the age of 5? Oh, 2 children under the age of 5, 28%. And let's see, does this ask us for, oh, okay, this does not ask us for a histogram. I was hoping it would. What percentage of households has 1 or 2 children under the age of 5? So 1 or 2 means I need to add those 2 columns. So that's going to be 60%, right? Because that's going to be a 10, carry my 1, and so 60. And again, you might have different numbers, but it works the same way. All right, so let's see if we've got one that talks about here we go. So, and I even gave you an instructor tip. You can open the data in StatCrunch to sort and to create a histogram. So let's open in StatCrunch. And then the first thing I want to do is for my data, let's see. No. Oh, there we go. Sort. So sort all columns. There's only one, so that I can leave that. Sort by variable 1 ascending. Compute. Now I have the smallest to the largest. Okay, so it asks if an appropriate lower class limit or an appropriate lower class limit for the first class is. And then we just want to pick a nice number. And if since my smallest number is 113.9, then I don't need to go all the way down to 0. And if I start at 200 or 500, I'm not going to meet all my data. So that hopefully that's an easy question. And then a class width of, well, in order to know what the class width should be, we're going to take the range of the data. And so we can do that actually by finding the range or just subtracting. So 13 I'm going to pull up my calculator here. Maybe I am. There we go. So calculator. And we're just going to subtract 1354.5 minus, and if I'm remembering, it was 113.9. So the biggest number minus the smallest number, that tells us how spread out our data is. And then if we divide that by 13 classes, should be around 95. So let's see what our options are. And again, we've got nice numbers here. So if we do 50, we're going to have way more classes. If we do 1,000, we're going to have like 2 classes. 500 might have, you know, like 3. So again, we just want to get a nice number close to this number here. So 100. And then it goes ahead and gives us our classes. So we just need to do the frequency. And again, so I can make that happen. So variable 1. And then we want frequency and relative frequency. I think we'll just do frequency right now. We can always go back and edit. I'm hoping it's going to let us. Yes, I do. Okay. Let's see if that now gives us. Well, okay, well, I'm not seeing the easy, but there is an easy way to do it from here. I thought we'd be able to make the frequency table here, but it didn't give us an option for how many classes or what our number should be. Also, to be fair, this is bad. 0 to 200 and then 200 to 400. If we had exactly 200, then which one would it go into? So this not only doesn't have the right numbers, but it's also kind of misleading. We should never, ever have overlapping. So notice here, 100 to 199.9, and then 200 to 299.9. So that's what we should go by. Now, I can also just look here. And so if I notice, I have 4 numbers that are in the 100s. And so all of these numbers in the first class I have here are going to have a 100 as the first digit. So there are 4. And then, oh, it went over here. So be careful. Use your mouse. 200, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So again, if I highlight all of the 200s, I have 17. And again, when I hit enter, it comes over here. So I've already forgot using your mouse. And then let's see how many 300s. 9, 10. Oh, nope. So 8. 1, 2, 3, 4, 5, 6. Yes, 7, 8. And I'm going to pause the recording so I can go ahead and finish this. I don't think y'all need to watch me do all of these. It's just counting as we go down our list of data in order. All right, so we got the frequencies down. Now, I just realized that if we were to go in and graph our histogram, And of course, we only have one variable. If we do the frequency histogram, so I'm going to do that right now just so I can show you. This allows us to select our bins. So we're going to start at 100 and have a width of 100. And then we should be able to, I don't think we need anything else. I think we can just say compute. And notice we have our histogram. And so we can, if we look, let's see, let me scroll back to my numbers. So if we look now, we see the frequency of 4, 17, 8, 11, 2, 8, and then there's nothing here, but it won't tell us 0, but there's no line. So we can do zeros all the way up until we get here. And notice now it's correct. See that it has this square bracket for the 1300 and then an open parenthesis for 1400. That means all numbers starting with 113, including 113, and going up to 1000, or sorry, I said 113, 1300, I apologize. Going up to 1400, but not including 1400. So just going up to that, and then that open parenthesis, if you might remember from an algebra class back in high school, square brackets mean we're including the value, and parentheses mean we're not including the value. So that's one way to get the frequency without having to highlight. I just picked the wrong thing to look at. So this is a good way to do that. And then if for the next part, it wants us to do the relative frequencies. So I can do my options. I can edit this same graph and just change this to relative frequency and click compute. And the graph looks exactly the same except for the vertical axis. And now when I hover, it tells me my relative frequency. So again, you don't need to watch me typing all these in, but I'm just going to type in these relative frequencies for each of these, and then I'll come back and let's see if we've got a few more parts to do, and let's see what we can make sure there's nothing else in StatCrunch that we need to look at. Okay, so next we want to find the correct frequency histogram, and of course we've got one to compare. Now this is the relative frequency. Remember, the graph will look the same. The only difference, and I can go back and change it to frequency again if I want to, is just the numbers. So, and it looks like all of these have a vertical axis that goes to 18. And so it looks like we have one that's lower, one a lot higher, and then down again quite a bit. So I think this right here matches up pretty well. This is going in the opposite direction, right? So this definitely doesn't work. And then this has some things here where there aren't any. So it would really kind of be between A and B, but this is the one that matches. And then same thing for the relative. So again, other than needing to change for the axis, we're just looking for the shape of the graph. That's the one that matches. And then our last question, describe the shape of the distribution. So if you watched either the interactive assignment and or my video for chapter 2, then I talked about the shapes. You have 4 shapes that we really kind of will look at. The uniform distribution goes straight across. A symmetric distribution, or what we'll end up calling a normal distribution, is bell-shaped with a single peak. And then we have skewed left and skewed right. So in the skew, when we talk about which way it's skewed, we always talk about which way the tail extends the longest. And so if I were to draw somewhat of a smooth-ish curve over this data, and this isn't very smooth because I'm having to use my trackpad, but it would look like this. Ooh, well, sort of. And close enough. And so that would definitely be skewed. and it's skewed this direction, which so that'd be skewed right because the right tail is longer than the left tail. So I'm going to clear that drawing. But so we want to say skewed right. So we can kind of automatically, it's not symmetric. It's not skewed left. So it's between A and D. And then it's a matter of, do we know the actual definition for skewed right? And for skewed right is where the right tail is longer than the left tail. Okay, so this right side extends further out than the left side. Okay, so we'll pick D. And excellent. All right, I think that might cover everything that we talk about in, except for, oh, you know what? There's cumulative. So let me see if I can find a problem with cumulative and relative cumulative frequency. And we'll do that last thing. And then I'll close this video out. Actually, I looked at the next problem and I noticed that we have dot plot. So again, if you could probably just do this visually, but quicker, again, would be to open in StatCrunch. And then dot plot is actually one of the graphs we could make. So if I go to graph, whoop, there we go. Box plot we'll do in the next chapter. Dot plot, of course, this variable. And I think everything else we should be able to leave alone. Let's see what happens. There we go. And so we should be able to see which one of these looks like this. And I believe it's probably this one. And I'm looking at between C and D, there's a couple of things. There's only one that should be here. And there's also too many here. So I believe D would be the answer. Then I'm going to let you go ahead and work through the rest of that. Now let me see if I can find a cumulative frequency. All right, so you'll actually come to stem plots first. And again, I want to show you how you can use StatCrunch. So if we open in StatCrunch, it gives us both of our data sets separated like this. And then stem and leaf, that's a stem plot. Now, it will let us select more than one. Let's see if it does a back-to-back like we want. And then we don't want any trimming. So compute. Nope, that just put everything together. Oh, no. Okay, I'm sorry. It put your best actors, and then on the second page, you've got your best actress ages. And so what you'll need to do, though, for this one, and I did include that in the instructor tip, so make sure you read these. I put these in here myself. So the numbers on the left should be listed so that the smallest number is nearest the stem. So you're going to type it largest to smallest. And then the right would be normal. So for the best actress, you can just put these in just like it's typed here. But for the best actor, you're going to have to do it backwards. Of course, there's only 1 7, so that's fine. Let's see, does it tell us if we need to? Okay, I think we can just put a space. So 4 1 0. Notice how I'm doing those in backwards. 9 9 8 8. Oh, don't need that extra space. 3 1 1. Let's see, 6. Uh-oh, I got off somehow, didn't I? Oh goodness. Okay. This split it into. Oh, let me see if I can fix that. Edit. It does not. Okay, so be very careful. I was not paying attention. Notice that this has 2 stems with the numbers for 3. So I actually need in front of that 410 and 9988. And then my 40s are gonna be 8, 8, 6, 3, 1, 1. See what I'm having to do there? And then 5s I only have 1, even though there's an empty one here. So I only have to worry about 4, 0, 0, 0. And then for 6, it's 2, 2. So that's best actor. And then for best actress, I can just put these in 0, 3. I wonder if, I'm going to try, if I don't put any spaces, I wonder if it'll give it to me. I'm going to see what happens. Oh, I'm doing the same thing. Shoot. You really got to pay attention. I wasn't, again, even though I just told you all that you got to do the same thing I'm doing. So 2, 3, 4, 4, 4, 6, 8, 9. So again, I'm going to see what happens. I put spaces on the left-hand side because that's the way I would normally do it. I'm doing it without spaces to see if my Labs Plus cares and is going to end up marking it wrong or not. 0, 0, 3. So let's see what happens. It was actually okay with either way, interestingly enough. So it did not care if I put spaces or not. And then you want to do a comparison. I'll let you all kind of think about what the comparisons might look like. All right, and then the next question actually does have cumulative. Yes, that's fine. I do want to leave the question. Cumulative and cumulative relative frequency. And so let's go ahead and open that in StatCrunch. And let's see, I think when we do just checking all of the, I think when we do histogram, the type, let's try this. Nope, that is not it. Okay, let me go back and I'll pause just for a minute. Let me find where we do our cumulative and cumulative relative in StatCrunch, and I will show you what I find. All right, so this is actually going to take a couple of steps. So if you look, the under ogive, I know that's a G, but it makes a J sound. You've got cumulative frequency or relative cumulative frequency here. So what we want to do is we want to enter the upper class limits in variable 1, and then the cumulative frequencies in variable 2. So we're actually going to have to come up with these first. So what I'm going to do is I'm going to open this in StatCrunch and get the frequency, because I can come up with the relative frequencies if I can just get the frequencies. So let's see if this will, so when I do a histogram, I will do what a frequency. I'm starting at 1,000 and oops, I hit enter and I meant to hit tab, with a width of 1,000. There we go. That's not very exciting as far as a histogram goes, but that's okay. So my frequency is 6. So that means my cumulative frequency here will be 6 because there's nothing before. So hopefully that makes sense. So if this is my first class, then the cumulative frequency is still going to be the same. Next, for this next class, My cumulative frequency is going to be anything that's in this spot or below. So I'm going to not just have a 2, that would be the frequency. I'm going to have 6 plus 2, so 8. And then I'm going to do the same thing here. So anything that is from here down. So this is another 6. 6 plus 8 is 14. And then, of course, 2 more will make this 16. So those are my cumulative frequencies. Now, my relative cumulative frequency is going to be each of these numbers divided by the total. And there are 16 of them. So one thing I can do automatically is the last cumulative relative frequency should be 1. Because if this is the last class, then everything should be either in the last class or below it. So that would be 16 out of 16. That's going to be 1. Now, as far as these others, I can either do them as a decimal, or I can do it says to do the upper class limit, but I'm going to do the lower class limit, and I think it will be okay. Well, let's do that. And then 6, 8, 14, and 16. Let's see if this will work. So I want to do, well, what did it say? Let's go back here. Select graph. Oh, and highlight scatter plot. Oh, I see what's going to happen. So we're just going to make the dots. So scatter plot, variable 3, variable 4, and then let's see, did it say to do anything else? The first class with a cumulative frequency of 0, and then graph. Highlight points and lines in the display window. Okay. So we want to hit the control, or if you're using an Apple, I think it's shift click. So we want both of these, and let's see what happens. Yeah. So that's the graph, but that doesn't help us much as far, because we have to go ahead and get those numbers. So let's see if 6 divided by 16, 8 divided by 16, of course, that would be 1/2, 14 divided by 16, and then 16 divided by 16. Let's just see. Oh, and then 0. If I do a scatter plot with variable 3 and variable 5, points and lines. Nope, I did not like that. It didn't like me putting those in as fractions. Okay, so that's just going to be a calculator problem. I thought we'd be able to do something with StatCrunch for these, but apparently not. If we have the cumulative relative frequency or the cumulative frequency, we can draw a graph. But as far as just getting the numbers, we're just going to have to do that semi-old school and use our calculator. So luckily, I had 2 of them that were nice. Of course, this last one's always going to be a 1. 8 out of 16 I know is a half. So I just need 6 out of 16. And it says to round to 3 decimal places, which is not really rounding at all. It's just the number. And then I need 14 divided by 16. So 0.875. And then we should be good. Excellent. So there we go. Sorry, I thought that was going to be a little more illuminating as far as using StatCrunch, but for the cumulative relative frequency and the cumulative frequency distributions, I guess just use your calculator. And that's okay. Now you can use it to get the frequencies so that you can add these up nicely, I guess. So that would be fine. I guess too, we could have done histogram of this column and done relative frequency and compute. Oh, sorry. I forgot to set my 1000. Keep hitting enter. I'm sorry. This is making this video longer than I want it to be. 1000. Now compute. And we can see the 0.375 plus 0.125 would be 0.5 plus 0.375. So I guess we could do that. That would be easier, maybe, to change that to relative and then just add. So the main thing is that the cumulative is just adding each of these up. So, okay. Hopefully that's helpful. I'll try and do this again with chapter 4 once we get, or chapter 3 and chapter 4 once we get into next week. So if you're working ahead and you have questions about StatCrunch, then by all means you can ask. But I'm going to try and kind of stay on point for those who are working along with the schedule that I posted. If you're working ahead, that's great. Please don't stop, but just ask me. You can ask me questions or look at this StatCrunch guide and see if you can figure out what to hit or what to use in order to do the chapter 3 stuff. So chapter 3 starts here on page 4. All right, I'm going to close out this video. Again, sorry it ended up being longer than I meant for it to be. It's I usually try to keep these short, but you can kind of skip around on this one as need be. So hopefully it won't be too bad. Y'all have a great day. Let me know if you have questions.